Okay, on to chapter 9. This will be our first official geometry chapter of the year. This will be some review and some new stuff, and it is important that you get all of it because we're going to stack all these transformations together. Okay? So here we go. A little bit of review. A coordinate point. These are points on a graph that are x, y kind of points. Okay, and I ask, how do you graph negative 3, 4? This would be left 3 and then up 4, and then we put a dot. Okay, so it'll be on your graph, here's your graph, left 3 and then up 4, and you're going to put a dot right there. Okay, need to remember that. X comes first and then Y every time. Which axis is X? This would be the horizontal axis. And then which is Y? That would be the vertical axis. Alright, a transformation. This is what chapter 9 is all about. It is a change in position, in shape, or in size of a geometric figure. And we are going to use a lot of coordinate plane geometry. You can do it just in general, just a shape sitting on a wall somewhere or on a floor or something like that. We're going to put it on a graph just for simplicity so we have numbers to count and that sort of thing. Alright, a little bit of vocab that you need to understand. The pre-image, this is the original figure before we do anything to it. This is what we start with. And then the image is the result after you move it, after you slide it, flip it, rotate it, whatever. That would be the image. This word right here, kind of important. You're going to hear this a lot. An isometry. This is a transformation in which the pre-image and the image are congruent. Okay, there's only a couple different transformations we do that are isometries, and there's some that are not. So we're going to talk about which ones are and which ones aren't eventually. Alright, so is this an isometry? Is the pre-image and the image congruent? The answer is no, it is not. Is this one an isometry? This is just a reflection. So the pre-image and the image are congruent. So this is an isometry. How about this one? Another reflection. So yes, it is an isometry. Alright, a little bit of notation. This is going to look a little different to you. When we move a shape, we may start with triangle ABC, but then when we move, why is it writing? But when we move the shape, we put these little apostrophes. It's called prime. So triangle ABC gets slid or rotated or flipped or whatever. That's what the arrow means. And it becomes triangle A prime, B prime, C prime. And then let's say you moved it again. Then it would be triangle A double prime, B double prime, C double prime. You could go to triple primes. You could go to quadruple primes. I've seen quite a few. But at some point it gets redundant and we rename the shape. Alright, so in this picture down here, it says that E prime, F prime, G prime, H prime is an image of E, F, G, H. So first question, name the images of angle F and angle H. So if I start at F and I slide it over, I end up at F prime. And if I start at H and I slide it over, I go to angle H prime. Okay, because the pre-image is the one without the primes. The image is the one with the primes after we move it. And then we'll list the pairs of corresponding sides. Let me get rid of this. Pairs of corresponding sides. So if I have EF, that is the same as E prime, F prime. They're corresponding. They match up. FG matches up to F prime, G prime. And then GH matches up to G prime, H prime. And then EH matches up to E prime, H prime. Those are all corresponding sides because they match up between the two shapes. Okay, the first transformation that we're going to do, and probably the easiest that we're going to do, is called a translation. It's a slide. You're going to take all the points of a figure the same distance in the same direction. So they're all going to go right and up, or they're all going to go down, or they're all going to go left. But all the points move the same direction at the same time, so that you start with a shape and you end with the same shape. All right? The rule, they usually put an XY here. This time I just put a 2, 3 because that's the point I was talking about. The rule will tell you how much to add to the x coordinates, how much to add to the y coordinates. So this particular rule right here says to go right 4 and then down 2. Okay, if this was x minus 4, we would go left 4. If it was y plus 2, we would go up 2. So that rule tells you what way to go. Alright, so let's try this. We've got this triangle, and I want to find the image under this translation, x minus 2, y minus 5. This tells me that I go left 2 and down 5. So every point of the triangle, I'm going to go left 2 and down 5. So I'll start with z. I'll go left 2 and then down 5. And that is now z prime. Go left 2, down 5. This is x prime. And then left 2, down 5. And this is y prime. So this is your new shape. Okay? With every shape, after you move it, I want final coordinates. So x prime is at 0, negative 4. Y prime is at 4, 1. And then z prime is negative 4, 1. Okay, every time I want you to put the final coordinates, because sometimes you don't have to use the graph, you can just write the coordinates. Let's go try another one. Alright, same triangle. This time it's x minus 4, y plus 1. This is left 4, up 1. So we go 1, 2, 3, 4, up 1. That's z prime. 1, 2, 3, 4, up 1. And then 1, 2, 3, 4, up 1 for x prime. Alright, new coordinates. X prime is at negative 2, positive 2. Y prime is at positive 2, 1, 2, 3, 4, 7. Positive 2, 7. And then z prime, 1, 2, 3, 4, 5, 6. Negative 6, 1, 2, 3, 4, 5, 6, 7. Negative 6, 7. Okay, every time. Alright, this time we're going to go backwards. I want a rule this time. We start at PQRS and we go to P prime, Q prime, R prime, S prime. So you need to look at 2 points that are the same. So let's look at the P's, okay? P starts here, moves to the left, and then it moves up. So we need to write a rule for this. So I'll put XY and then the arrow. And if X moves to the left, it's X minus. So we go 1, 2, 3, 4, 5, 6, 7, 8. X minus 8. And then it goes up, so that's y plus 1, 2, 3, 4, 5. Y plus 5. And you can check all of your points, and it should work for every single point. Like if we went to R and we went left 8, up 5, it would go to R prime. Okay? So we're just going backwards from what we were given before. Alright, this time I didn't give you a graph, because we don't necessarily need a graph, right? We want to write the rule. We start with LMN, and we go to L prime, M prime, N prime. So we'll start our rule. Alright, let's just look at L. In order for us to go from negative 6 to positive 1, what has to happen? We have to add 7. Negative 6 plus 7 gives me 1. And then on the y's, I go from negative 1 to negative 2. That would be y minus 1, because negative 1 minus 1 gives me negative 2. And you can check this with all the other ones. If I take negative 4 plus 7, I get 3. If I take negative 3 minus 1, I get negative 4. Okay, so our rule works. All right, then we have this thing called compositions, and this just is a combination of two or more transformations. So you slide, then you slide again, or you slide, then you reflect, then you slide, then or you rotate, reflect, then you slide, something like that. This is kind of the important part of this. Each transformation is performed on the image of the preceding transformation. So you don't go back and use the original shape. You use the new shape to move it wherever it needs to go. Okay? So word problem is a good part of this. Let's say we have our friend Yolanda, and she is visiting San Francisco. From her hotel, so we'll draw a hotel here, put H on it. She walks 4 blocks east, 4 blocks north to the Wells Fargo History Museum. So if she goes 4 blocks east, and then she goes 4 blocks north, she is at the Wells Fargo History Museum. Sounds exciting. Then she walks 5 blocks west and 3 blocks north. So she goes 5 blocks west and then 3 blocks north to the Cable Car Museum, which is just another exciting day. How many blocks is she from the hotel? So I want to know how far she is right now. Okay, so if you look at how we drew this, she went 4 east, but then she came back 5 west. So she's only 1 block west of her hotel. And then overall up, she went up 4, and then she went up another 3. So that's a total of 7 north. So she is 1 block west and 7 blocks north of her hotel. So if we were to tell her that how to walk back to her hotel, we were trying to give her directions, we would tell her to walk 1 block east, 7 blocks south to backtrack and get back where she was. Okay?